Hello guys, today we are going to see linear search algorithm, one of the basic and naive searching algorithm in data structures. It's used to check an element is present or not in an array. Let's see an example. One, 5, 6, 7, 3. This is an array with some integer elements. Let's write a target equal to 7. Our task is to find this target element is present in the array or not using linear search. As I told earlier, linear search is a simple approach to check an element is present or not in an array. Let's start from the first element. Let's write the index first. 0, 1, 2, 3 and 4. Let's check the first element is equal to our target or not. Here the first element is 1 but our target is 7. It's not equal to our target. Then move to the second element, which is first index 5. Here the element is 5 but our target is 7. This is not the element we need. Then move to the next element, which is 6. This is also not our target element. Then move to next element. Here the element is 7. Our target element is also 7. We found the element. Then we can straight away return the index of the element or simply return true based on our requirements. After finding the element, we don't need to traverse the remaining element in the array. We can simply break the loop and return the element. Let's see another case, what happens if the target element is not found in the array. Here we can see the target element is not there in array. In the 0th index, the element is 1 but our target is 10. It's not equal to our target. Then move to the next element. This is also not equal to our target, and this cannot be our target, this cannot be our target, this cannot be our target. Suppose if we traverse the entire elements and if we couldn't find the target element, we can straight away return -1 or false. This is based on our requirements. Let's move to the code editor and let's write the code. First of all, define the linear search function. It receives two arguments, array and the target value. And I'm going to store the length of the array in the variable n. Let's write the for loop. This for loop will run from 0 to n minus 1. Let's check whether the current element is equal to the target or not. Array of I, which is current element, is equal to target. If this is satisfied, actually we found the target element. We can straight away return the index of the array. Otherwise, we can return simply true. Whenever the target element is found, it will return the index of the element and then stops the loop and return from the function. Suppose if the target is not found, we can simply return -1. This statement only executes if the target element is not found in the array. Let's define the array. Let's write the target element 7. Let's call the linear search function and pass the array and target. I'm going to print the element that is returned. Let's run the code. The output is 3, which is the index of the element 7, 0, 1, 2, 3. Let's give another target value 3. Yes, the output is correct. Let's give an element which is not found in the array. which is 18. Yes, we got the expected output -1. Let's analyze the space and time complexity. Linear search typically consumes big O of n because we are traversing the entire elements. For example, if the target element is 4, it will traverse from the first element to the last element, which is the loop will execute n times. Big O of 1 is average and worst case scenario, but the best case is time complexity is big O of 1. Suppose if in this array, if the target element is 1, we can get the element in the first iteration. There is no need to traverse the remaining elements in the array. Then the space complexity is also big O of 1 because we didn't use any extra space in our code. Thank you.